Hello, everybody, and welcome back to the Aquarium of the Pacific's Online Academy. My name is Dana. I'm a member of the Education Department here at the Aquarium, and today you're going to be joining us for a really special program. We're going to be doing a squid dissection. Okay, so we're going to be spending a lot of our time over at another camera. You won't actually see me, but you'll be seeing my hands and you'll be seeing the squid in front of me. Now, this program's going to run the same as all of our others. If you feel like you want to participate, we highly encourage you to do so. That number is going to be right down here. It's 562-286-1838. We're going to be taking questions live as we do our dissection, and I really like to cater my dissection around what you are interested in. So if you want to learn more about a certain body part, feel free to give a shout out, and we'll see if we can explore that and discover a little bit more about our squid. Now remember, texting rates do apply, and please make sure you have adult permission to join us today. Otherwise, we're going to get started right here. We're going to take a look at a couple relatives of our squid and see if we can notice any shared characteristics between them. So what about this one right here? What do you see there? Well, this is a California sea hare. Now, it's a very squishy animal, very soft, okay? This is in a group of animals called mollusks, and then squid are in that group as well. So soft-bodied is one of those shared characteristics. Let's see if we've got any others. Ooh, interesting. Now, this animal's a little bit different right here. If you can see, this actually has a hard shell. Now, the slug didn't have that, the sea hare, nor does our squid. However, underneath this shell right here, they do still have that soft body, okay? So it's going to be a little bit different because of that shell adaptation, something that helps it survive. But underneath, it's still going to be that soft mollusk body. What else have we got? Ooh, so this one's a little bit different as well because unlike our last shelled mollusk, this one actually has two shells. It has one on top and it has one on the bottom there. Now this is a type of scallop right here, I believe. And scallops are in a group of animals that we call bivalves. Okay, so they have two different siphons or valves to help move the water and move nutrients through their body. So these are our bivalves. Any other relatives we got up there? Aha, another single mollusk. This is our Kellett's whelk, okay? And this is actually a local animal. They like to hang out right along our coastline. And what's special about this snail right here is it's actually a predatory snail. It's not feeding on algae like a lot of its friends. This is a carnivore or meat eater. And so they have a very, very strong, it's called a radula. It's like a tongue, but it's really rough, and they can actually scrape a hole and drill into their prey, which is going to be other mollusks inside of those hard shells. So this is an example of just some mollusks, okay? It's going to be all of our soft-bodied invertebrates like snails and slugs and limpets like we saw before. And there's one other group of mollusks, which are going to be which is going to be one of these animals right here. This is an octopus. You can see it's got the eye right there. It's a little flattened right now. And then it's got this, zoomed in. We got a siphon over here. We're actually going to explore that on the squid. Now, our octopus and our squid that we're going to dissect are in a more distinct group of mollusks known as cephalopods, meaning head foot. So it's kind of got the whole body, and then it's got the arms, and that siphon is kind of the rolled up foot. Now, this is another animal within that group of cephalopods. This is our cuttlefish. So you can kind of see the similarities between an octopus, a cuttlefish, and a squid. We're going to take a really good look at our market squid right here. This is actually the animal that we're going to be dissecting today. Now, we do have some questions coming in, which we really love. So once again, feel free to text us at 562-286-1838, and we'll be able to answer to the best of our ability. We have Gage joining us again. Gage wants to know, do squid swim in deep water? That's a great question, Gage. Now, I have a question back for you. Why did you think that? Why did you think squid like to be in deep water? Where did you pull that information from? Well, there's a lot of stories about squid in the deep sea, especially giant squid And, ooh, and this one right here, look how blue and open that water is right there. This is not a giant squid. This is actually a Humboldt squid, another species, but I don't know, it looks pretty giant to me, right? Now, squid do like to live in deep water. When you talk about giant squid, you're usually talking about their fights with sperm whales, and that's down in the deep depths of the ocean. But even our little market squid like to live in deeper water. They spend their days down deep, and then at night, squid do something called a vertical migration. They actually work their way up to the surface, oftentimes getting drawn towards the moonlight. So vertical migration is a little bit different than migrating from like one part of the world to the other. So let's go back to that market squid picture real quick. Right here. What are some first characteristics that we might notice about this animal right here? What do you think? Well, I notice that it's got a really big eye, right? The better to see you with. Now, squid actually have the largest, one of the largest eye to body ratios in the animal kingdom. So if this squid were to be like my size, for example, how big do you think the eye would be? Do you think it would just be my size? Or would it be really, really big? Yeah, giant squid, in fact, their eyes can be the size of dinner plates. Okay. What else do we notice about this animal? What do we see here? Ah, I noticed that there's little spots all over it. What are those? So those are something that our cephalopods have. Those are called chromatophores, okay? And I love chromatophores because it actually helps them camouflage and blend in with their environment. It also helps them, more specifically with these animals, communicate, right? They can't use their words. They're not swimming around talking to each other, but instead they use flashes of color, which is what these chromatophores allow them to do, to give warnings or look for friends or mates, right? Anything like that to help them communicate with each other. Let's take a look at our special camera and see if we can find our chromatophores on our squid. Okay, let's see. So these are two market squid. They look a little bit different, right, than that one that we just had on the screen. These market squid are dead. We're not cutting into a live animal right now. These were we actually feed these animals to the rest of the animals that we have here at the aquarium. This is a market squid. It is harvested sustainably. In fact, this is actually restaurant quality sustainable seafood. Now, what does that mean? Well, I said we feed it to our animals. And so when I say restaurant quality, it means that they're getting the best of the best. If you were to go order squid, usually known as calamari, at a seafood restaurant, you would actually be ordering the same kind of food that we give to our animals here. So restaurant quality, meaning you would be eating it as well. Sustainably harvested means that it was caught in a way that did not affect the natural habitat, the population, and in a way that there's going to be squid around for harvesting for a long, long time. That's the idea behind sustainability. So, like I said, they don't look like that photo we were just looking at, but what do we notice? I do see those polka dots right there, right? So we mentioned the chromatophores. Let's see what we've got there. Those are the polka dots right here. Okay. I'm going to go ahead and zoom in just a little bit here. Whee! So if you look there, those are those chromatophores again. Right around here. Now, what do you notice if I were to turn this squid over? What color are the chromatophores on this side? Well, it looks like it's a lot more red up here, right? And all along the edges, it's a lot more red. Whereas on the other side, it appears a lot darker, more black. Now, it kind of looks like the ink sac of this squid might have popped. So it's going to look a little bit darker than it actually is, especially with the lighting on this camera. But you can still see that the spots on this side are black as opposed to that red that we see right here. So like I said, they use it for communication. Squid are able to flash different colors depending on what kind of communication they're looking for, right? So awesome. See if I can zoom out here again. There we go. So there's our squid. All right, let's jump back to that photo one more time. Okay, so we talked about The eye, right? We noticed the chromatophores. We also explored those on our squid that we're going to dissect right now. What about these parts right in the front here? What exactly are those? Can we talk a little bit about them? Well, those are what we call arms and tentacles. Now, they're different things, okay? Oftentimes, we refer to the arms of an octopus as tentacles, especially in the joke. How many tickles does it take to tickle an octopus? And we usually say 10 tickles, right? Like tentacles. However, we do refer to those as arms. And we're going to take a closer look at what an arm versus a tentacle is on this squid. Octopus have 8 arms. Squid have 8 arms plus 2 tentacles. So let's go see if we can find 8 of one thing and 2 of another. Let's check it out. All right, we're going to use our little guy. So we've got, well, those 2 seem to be longer. All right, let's see if I can use this. It might be a little bit easier to count. And it looks like we've got 1, 2, 3, 4. This might be really hard. 4, 5, 6. Oop, there was 2 there. 7 and 8. So, taking a look at this, what do you notice is the difference between the 8 arms? Once again, that's 1, 2. We're going to kind of cross these. 3. Come over here. 4, 5, 6, 7, 8 versus 2. 8 arms, 2 tentacles. Okay. Well, some things that I noticed off the bat, the arms seem to be a lot shorter. Okay. So the arms are a lot shorter. What else? These are really long. Okay. Now, if we get really close here, again, I'm going to zoom us in. Bear with me. Might take a second to get where I want it. Whee! Whoop. All right. So if you can see on this arm right here, right over here, there are also what look like little baubles. Those are, in fact, the suction cups. Okay? Just like the octopus, just like the cuttlefish, they have suction cups right here. But what about the tentacles? Do the tentacles have suction cups on them? Well, not at first glance. However, if you were to look on the end of the tentacle, it's very small. Maybe we can look at the one on the bigger one. There are just a few suction cups on the end, okay? So again, very tiny, so it's hard to see, but they're on the end. Now, there we go. Look at that. There's an arm. There's a tentacle. I love it. So, on an arm, the suction cups go all the way to the tip. And then on the tentacle, ready? Ooh, wait, wrong way. Ooh. There's only suction cups on the tip, okay? So these are the 2 things that I want you to kind of pay attention to as we're going throughout. And we might come back to it and recount the 8 versus the 2, because I really want to drive home that arms and tentacles are different. But what was the question? Why are the arms different colors? Good observation. Now, some of it might just be because of the angle we're catching it. This one is the top, so it's covered in those chromatophores. Okay. This is the bottom of one. We're looking at the suction cups as opposed to the tentacles. So if I were to flip this one over, it might look, well, I think it also might just be the lighting of the camera there. It's also laying in a little bit of that ink down here, so it could just be getting colored from that. But for the most part, if it's darker, you're looking at the top where the chromatophores are, and if it's lighter, you're looking at the inside where the suction cups are. That was a really great observation. All right, so like I was saying, we're talking about the difference between the 2, but what I want to know is why do they have arms versus tentacles? What's the difference as far as use goes? Okay, now for this, I actually want to pull up a picture of a jelly. All right, we're going to throw James a curveball there. Pull up a picture of a jelly, and we're going to see if we can see something similar on those animals. All right. So you might be thinking, what, a jelly? Let's see what we can discover just by looking at one. Aha. Ooh, you gave me a hard one. All right. So, do we have a picture of the sea nettle? So this one's a little bit harder, but if you notice all these long, stringy tentacles on this one, we're going to keep an eye out for those on the other species of jelly as well. All right, so that'll pop up here in a moment. But what I want you to notice is that just like our squid having arms versus tentacles, our jelly has two different types of tentacles coming off of its body. There's going to be some that are long and skinny, and there's going to be some that are a little bit frillier and a little bit shorter. So we're going to pull that photo up here and see what that's going to look like. All right. But while we're doing that, once again, we'd love to hear from you. We'd love to have your participation. Go ahead and shoot us a text at 562-286-1838. All right. That's where we're going to be able to take those questions, just like we took Gage's question a little bit earlier in the show. We want to be able to answer whatever things you're wondering about or anything you want to discover more about our squid. So while we're looking for that jelly picture, let's go ahead and jump to the special document camera. There we go. Or our squid camera, I should say right now. All right, so let's take a look here. We also talked about the eyes. All right, so let's take a look at these eyes here. They're very, very big. But there's one thing that I mentioned. We're going to come back to these tentacles versus arms here in a little bit. We're going to try to find that photo I was mentioning. So another characteristic that our cephalopods have is something called a siphon. All right, so let's see if we can find this squid siphon. Now, I like to tell my friends who are doing dissections to look for what looks like a little macaroni noodle. And if you're looking at the screen and you think you found it, let's see if you are right. So if you were looking at this, kind of looks like a little macaroni noodle, right? Like a little elbow-shaped pasta. Now, that siphon is really important because that's actually going to help a squid move, okay? So we're going to see if we can get that jelly photo, but if not, let's check out a photo of a squid moving. Ah, the jelly photo. Perfect. This will do. So this is from our website. Now, I mentioned those long, stringy tentacles right here, okay, down here as well. And then those a little bit frillier tentacles in the center. Now, the way a jelly uses these is some of them are stinging and they kind of catch the prey. They're the long, skinny ones. And then the rest of them in the center, the frilly ones, those are called oral tentacles. And what the long, skinny ones do is they're the ones going like this. They catch the food. They transfer them to the oral tentacles, and then it moves it up in towards the oral cavity or the mouth of that jelly. So go ahead and, can you pull up a photo of a squid? I know I'm throwing you all sorts of... Can you do this and this and this, please? So we're going to get a picture of a squid up here, and we'll talk about what they do with those arms and those tentacles. But it's the same as this. Aha, check it out. So this is, aha, they're grabbing... All right, they're grabbing with their arms, but in this video, they're actually looking for mates. But if they were catching food, they'd be doing the same things with those shorter arms. However, the tentacles reach out and catch their prey and bring them in towards those shorter arms, and the arms are what allow you to eat the food. So, aha, here's a cuttlefish. There we go. So they've got the same thing. They've got two long tentacles. Boom. Ooh, can we see that one again? That was cool. Slow-mo. So it's got prey. Those two tentacles reach out, and then they pull it back into the body to eat. Check it out. Look for the two tentacles. Ready? Vroom. So that's the difference between the two tentacles and the 8 arms. That was really, really good footage. We're going to go check out, or we're going to try to see if we can get that video of the siphon up here and see how our squid like to move. All right, so water's going to come into the mantle, which is this bigger part right here. You're going to take water in, and then it's going to shoot out that siphon right here, and it's actually jet propulsion. Okay, so let's go back to the squid dissection, see if we can find that siphon. There we go. So like I said, that little macaroni noodle. This big piece here, I'm going to zoom out, is the mantle. So same thing. It's going to pull water in and then shoot out the siphon, and it's jet propulsion. Now, we've explored a lot about the external anatomy. We checked out the chromatophores. We looked at the arms versus the tentacles. We've checked out the mantle and the siphon. Let's find out what it looks like on the inside. Are you ready? All right. Ooh, before we do that, it looks like we've got a couple. Oh, no, we've got some fun facts coming in. So these are some fun facts about our market squid. Landings in the 2016-2017 season were logged at 42,000 tons. Okay, 42,000 tons of market squid. And that equaled $41 million in our economy. Now, they usually spawn from April through October in Southern California. So we just kind of ended the spawning season, and females can make and lay up to 20 egg cases at a time. And correct me if I'm wrong, but I believe each egg case holds a handful of eggs. We're going to come back to that one, get an answer for you. Now, let's take a look at what goes on inside. So to do a dissection, we use special scissors here. One edge is pointy. 200 eggs per egg case. So you can do the math there. 20 egg cases, 200 eggs per egg case. We're pulling the calculators out, but you at home, I'm trying to give you homework. Now, like I said, we've got the pointy end and we've got the curved end here. We like to put the curved end into the squid. That way we're not mangling all of the internal anatomy. Okay, now I'm going to use the little one. I'm actually going to cut both, but like I said, I think the ink sac popped on this one, so I don't want to open one up and just have it be all sorts of mangled. So curved edge down. We're going to come here and we're going to pinch that squid. All right, there we go. And we're going to go doot, 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 doot. Now it cuts pretty easily. Like I said, it's a very soft-bodied animal. We're going to open it up. Oh, check that out. Is that what you were expecting? Now, if it's not what you were expecting, what were you expecting? Okay, all the way up to the top. Ooh, this is interesting. Now, looking at both of our squid here, I can tell you right off the bat that both of those squid are males. But how did I know that? I mean, it kind of just looks like a bunch of gooey stuff, right? How did I know that both of these squid were males? Well, I'm going to try to pat some of this black ink up here. A little bit of blotting for you. I don't know, does that make a difference? It's kind of hard to see, huh? Okay, so this white cloudy spot right up here, that is how I identified those two squid as males. And we actually have a diagram of what a female squid would look like. You can imagine the female is going to have eggs. So that's going to be right here. Oops, we had it up. We're going to get it right back up for you. But at the tip of that squid, right, that was just on the screen, we'll pull it up again, don't worry. There's going to be a yellow kind of, I like to actually say it looks like petroleum jelly or like Vaseline. There we go, right up here. So it's all up in here. Those are the eggs. Now, we mentioned that females can lay 20 egg cases at a time, full of 200 eggs each. So she's going to have a lot of eggs here. And then this is called the nidamental gland. Okay, and this is actually where the egg sac comes from. So kind of comes out in a long tube-like structure full of 200 eggs, and they lay them on the sea floor. We kind of got a glimpse of what the mating behavior looked like a moment ago when they were flashing the red, okay, and grabbing onto each other. And at the end of that, we'll see if we can pull that video up again. You actually see all of the egg cases along the sea floor. So check it out. Right, you've got the chromatophores causing them to flash bright colors. Look at how quickly they can change. Isn't that amazing? So there's bright red arms. All right, now look at how many of them there are. This is usually done down on the sea floor. We've got those communication happening. We've got all those big eyes around, right? And then after the mating, like I said, those eggs will be everywhere. So we're going to zoom out here and see. Ooh, we're starting to see some. Check it out. So that's an egg sac. Right? Each female can lay about 20. And then inside that sac, there's about 200 eggs. So check it out. We're going to zoom out here in just a second, okay? And you're really going to be surprised. So here we go. Ooh, there we go. So there's the mini eggs. Here's kind of the tips of the egg sacs. And then as we zoom out, I'm going to let you figure out what that's going to look like here. All right. Oh my goodness. Look at all of those squid egg sacs. In fact, look, you can even see it like in the distance up here and over here, right? So you can see it just goes on and on. Look at all of those eggs. Isn't that incredible? And now the landing of 42,000 tons kind of makes more sense, huh? So, like I said, we have 2 males right here. Let's jump back to our dissection camera. We have 2 males right here, and I know that because they don't have that jelly-like aspect, which are the eggs, and they don't have the 2 white blobs, which are the nidamental glands. Okay. Now, what else can we identify? Like I said, it all kind of looks like mush. Now, if you remember, this is a soft-bodied animal, and it's also what we call an invertebrate. Invertebrate. What is that exactly? Well, if you've been tuning in, an invertebrate is an animal without a backbone. So as you can see, there's no skeleton inside of our squid here. So we can kind of check it out. We can explore, right? One of my favorite things to explore is the fact that this is an underwater animal. So if you look over here, you can actually discover the gills, which is how they get the oxygen out of the water. Now, right now, it kind of just looks like a clump, right? But if you were to put that in water, you would find that it's quite feather-like. And that's how it kind of increases the surface area in order to pull as much oxygen from the water as possible. All right. Now this little bit right here, boop, boop, right there, doesn't look like much, but it's slightly different color. That's actually the heart. What? Yeah, that's right. So it doesn't look like much, right? We think of our heart as having a lot of structure to it, but the squid, not so much. So this is the siphon again right here. Okay. And here, now you'll see that the siphon actually doesn't really open up to anything. Let me see if I can zoom us in a little bit. If you recall the jet propulsion, what happened earlier is water goes into the mantle, which is all up in here, and it's just open space. And then it shoots out the siphon. So we're actually going to find what that looks like. This is the open end inside the mantle, shooting out that smaller end. So that's the movement of water passing through that siphon there. All right. Now there's one other structure that I really want you to be able to check out here. Okay. That's going to be this little shiny thing right in here. What might that be? If you look over here, this one's got a tube, but it's a little bit smaller and skinnier. So if you remember what I've said about the difference between these 2 squid, why one looks a little bit cleaner than the other, that is because this ink sac popped, and that's going to be this little skinny silverfish-like thing right in here, like structure. Now this one is still nice and neat and put together. So what we're going to do is we're actually going to try to grab that ink sac. It's stuck in by really thin filament right here. We're going to grab that. Little tissues. We're going to cut it out. Whoops, sorry, I'm a little bit off the screen there. Now we're going to set that ink sac off to the side. So you might remember that a very, very charismatic characteristic of our cephalopods, our cuttlefish, our octopus, and our squid, is the fact that they ink. Okay, so let's take a look at this. It's not very big, right? See if we can get some ink out of it. See what happens. Now, why do squid ink? Right? Why do they ink? Well, it's kind of one of their main line of defense. So if you check it out, ooh, watch that. So it was a really small ink sac, right? But once you kind of get in there and it mixes with water, remember, I've kind of cleaned up our plate as best as I can, so there's not a lot of water involved. But you can imagine if water was involved, like in the ocean, that would really spread out and you would have a lot of ink, even from such a small ink sac, okay? And so they can use that in a number of ways. The most common is going to be as a escape mechanism. All right. So if you're chasing, if an octopus or a squid or cuttlefish is being chased by a predator, they can release that ink, and it kind of creates this really big cloud, right? Or it can also look like guts shooting out. It can look like a couple different things depending how much comes out. And that predator is going to go for that squishy, gooey ink as opposed to the octopus or the squid or the cuttle, and that animal is going to be able to get away. So it's a really cool mechanism. And I will tell you, it stains, all right, if you're not careful. We have had, it gets on your fingers, right? Squid dissections can be very messy, but they're very fun because you can explore a lot more of the animal than you can just by looking at the outside. So we've got our ink sac up there. What else do we notice? Well, I mentioned that it's an invertebrate, and yet it has this beautiful structure here. So our last piece of anatomy that we're going to explore in this animal is something called a pen. A what? Well, if they have ink, they've got to have a pen to go with it, right? Not quite. However, like I said, a lot of mollusks have that hard shell, right, for protection. Now, our squid no longer have that hard external shell. However, they do still have a slightly harder part in their body. I'm going to find it by grabbing the head and pulling it back from the rest of the mantle, basically removing this aspect so that we can see what's going on behind it. Then I'm going to pinch around here. Ooh, what's that? And we're going to pull it out. Boom. So this is what gives that squid structure. It kind of feels like a little bit of plastic. Oftentimes people will find it and be like, oh my gosh, there's plastic inside my squid. However, that's not the case. It's actually remnants of a shell. Through evolution, they no longer have that shell. But you can check it out and see that it does provide structure. Now, an octopus does not have this. So if you've ever seen a squid versus an octopus, you'll see that the octopus have a much more rounded head, and our squid tend to have that much pointier structure right there. So a wonderful dissection. I hope you all enjoyed kind of diving in and exploring that animal a little bit closer. This is our last program for the day, but we're going to be back here tomorrow morning at 9 o'clock. We hope to see you there as well. Again, you are always welcome to participate live during our program at 562-286-1838. But if you find yourself watching this after our live stream, we'd still love to hear from you. We do have a website or an email address available, and that's going to be live@lbaop.org. Once again, live, L-I-V-E, at lbaop.org. So text us your questions now. We're wrapping up, or go ahead and email live@lbaop.org, and we'll do our best to answer them. Otherwise, have a wonderful Monday afternoon, and we'll all see you back here at 9 a.m. tomorrow. Bye, everyone.